just a quick forward. In this episode, I was troubleshooting as I go, and I was discovering where the flow issues existed as I filmed. So you'll have to forgive some of the assumptions I make at some points in the episode. Welcome back to Hoochos. So today we're going to discuss flow rate, why it's important, and some common mistakes people make when setting up their NFT hydroponic system. Now, when I first dived into hydroponics, I considered going to uni and doing a degree in agricultural science and funneling my way down into the hydroponics within the agricultural degree that I wanted to do. But my experience with the university degrees that I've done says that all university does is teach you how to learn and then regurgitate information from textbooks. With that in mind, I went out and purchased myself some university grade textbooks on hydroponics and taught myself most of what I know through both the textbooks and in practice. Now, the information I'm going to be giving you today is out of the textbook, The ABC of NFT. It's written by Dr. Alan Cooper, who was a pioneer of NFT research in the late 70s, which is also when this book first went into print. The edition that I've got is a 2008 edition, which is the latest edition, and the book, I believe, is no longer in print. And it was really hard for me to get my hands on this copy, which is why I want to pass the information on in this format. So, to cut to the point, this textbook actually says there's a variety of factors to take into consideration when you are adjusting your flow rate. However, he does actually in the book give the ideal general flow rate for NFT hydroponic systems, and that flow rate is 2 liters per minute. So what I'm going to do now is I'm going to measure how fast my NFT is flowing so that you have an idea of what I've been running at for the entirety of this channel. And then I'm going to introduce you to ways that you can increase or decrease the flow of those NFT channels without having an adjustment on the pump itself, because you may be using different styles of pumps. Let's get to it. Now, to measure the flow rate of any given NFT channel, all you need is a container with measurements on the side and a timer. So you want to set your timer to 1 minute and then put the flow going into the container, and after 1 minute, you'll stop it, and that will give you your flow rate per minute. So my flow rate is 700 mils per minute. So you may have noticed that 700 mils per minute is slightly less than 2 liters per minute. That being said, that's either the maximum output of my pump or the maximum output of 2 4mm channels given the pressure that the pump outputs. So what I'm going to do now is I'm going to show you how to adjust your flow if your pump is too powerful and doesn't have a pressure regulator on the pump itself. So if your pump's too powerful and is pushing too much water into the top of your NFT channels, we can use these to adjust the flow. These are a 6-port manifold. Now, in the shops, they won't look like this. They'll look like this. Now, these are used primarily to control the flow of drip irrigation systems, but for our purposes, we can use them to control the flow of 4mm tubing going into the top of your NFT system. These are just poly risers. They're also used for irrigation systems, and this is a 13mm barbed end piece that fits the end screw for your poly riser. Together we can fit them to the top 13mm tubing and adjust the flow on all of our NFT channels. So at the start of this video, I actually thought that I'd need to just decrease the flow on my NFT channels. But now that I've measured them, I actually think I need to increase the flow. So with my 6-port manifolds, I've got 2 of them, and I've got 4 NFT channels, which means that I can put 3 4mm tubing going into each of my NFT channels, which should increase the flow substantially. So what I'm going to do is I'm going to tube up my 6-port manifolds. Then once it's all ready to go, I'm going to turn off my NFT system, plumb it in, and then I can play around with the flow rates on individual channels by adjusting these little flow rate adjustments on the top of each of the 6-port manifolds. This will give me some ability to experiment with different flow rates on each channel. And what you end up with is some kind of War of the Worlds deadly space octopus. It's actually terrifying. And now that I'm ready for a quick changeover, I'm just going to turn off the pumps and quickly switch it over. There we go. How much neater is that? Now I'm just going to drill some holes in the top and we can turn the pumps back on and see what our flow rates are. Okay, now I've turned the pumps back on. I'm going to turn all of my flow rates to high, and we can measure the rate of flow coming out of 3 4mm pipes. 700 mils. So what this tells me is I've actually reached the maximum output of my pump. Which brings me to the expensive part of the day, which is this. This is a larger pump. The flow rate on this is 2,800 litres per hour compared to my current pump, which is 1,400 litres per hour. So this should double my system's output. And as you can see, it's quite a bit bigger. Okay, now let's see how this has affected output of the 4mm tubing. Oh, what? So as you can see, I've got them working, and I thought it was the pump that didn't work at first. So I was like, because see, this one's not working. But the problem was, as I was working on the system, it knocked loose a ton of particulate. This one's not working now, but as you see, when I take this off, we have water flow. The problem is actually internally inside these 6-port manifolds, they have these. And I thought this was going to be really good for the system, like something that would stop the system clogging up. But what it's done, it's completely blocked. So if you are going to install these 6-port manifolds, make sure you take these out. This stopped the pressure on my larger pump, and I hadn't used it much, so I didn't think that it would be broken, out of the box. So it completely stopped the flow. So now I'm just going to replace this manifold, and we'll try again. All right, now let's try this again. And I've increased the flow to 1 litre per minute. Now, what that actually tells me is that the flow rate may not be dependent on the pump, but it may be bottlenecking at the 13mm tubing, which would probably be my guess. So if I do want to increase the flow rate on my NFT, I may need to increase the diameter of my tubing to something like 19mm tubing. So after all that, I was able to increase the flow of my NFT by a third. And with the new pump that I've got, I have the ability, if I want to increase the diameter of my piping, which is the bottleneck in my system, to a 19mm piping. Now, if you're just working with two NFT channels, 13mm piping would probably be adequate if you wanted to increase the rate above that 1 litre per minute rate. But if you were going to have another 2 rows and increase the capacity of your NFT to the full 6 that I designed to eventually be able to supply, I will be adding in 19mm or 3/4 inch piping to supply that needed extra volume of water. Now, in this discussion today, I'm not saying that you should go out and increase the rate of your NFT or decrease the rate of your NFT. If your NFT is producing decent results, if it's not broke, don't fix it. But if you're troubleshooting your NFT and finding that the growth isn't adequate, water is pooling because the flow rate is too great, these solutions may help you troubleshoot that problem. Now let's discuss one mistake that a lot of people make with NFT. Now you'll notice in my system that from the moment the water enters the pipes, it is gravity fed all the way down to the reservoir without interruption. There are no pipes increasing the level of the water. There's definitely no baffles in my system, and any attempt to stop the water running down the system doesn't exist. The only thing that may cause a backup in the system is the plant's roots themselves, and that is something that I have no control over. The reason for this is nutrient film technique is exactly that. If you have standing bodies of water in your system, you negate the entire purpose of the system. The standing water becomes anoxic, and the roots in the standing water can develop root rot and cause problems in your system. The reason that NFT is so productive is because the roots are in a shallow film of water, and the top of the roots are exposed to the air, and the bottom of the roots are kept moist by the nutrient solution. In a pipe system like this, the bottom roots cover the pipe and create a water level which allows the nutrient solution to flow freely over the top, and this gives the roots adequate amounts of oxygen and nutrient solution and water, And it also has some weird effects for the plants where we see greater tolerances to pH swings as well as nutrient EC swings. So they actually have a higher tolerance to higher ECs in NFT systems. I've seen a lot of videos of people making NFT systems where they use stoppers at the end to raise and lower the level of the water. And this is fine if you're using, net cups where you need, and you're starting seeds in the system where you need to pull the roots out. But if you're running the system like that full time, you're not getting the productivity that you will with an NFT system, and you're running an RDWC system, which is a recirculating deep water culture system. And it's probably not even that good. Uh, at best, I can see it having Kratky-like results, and that's because you're not getting the oxygen to the roots. Unless you had air stones all through a deep system like that, there would not be enough oxygenation in the system to promote vigorous growth. I'm not saying your plants won't survive, they will, but the benefits of NFT are completely nullified by those techniques. We've followed this rabbit hole a long way, so let's just go deeper. 19mm tubing. All right, it's all plumbed up, and I'm going to make it look tidier later. I just want to check that it works, so let's do that. All right. Oh, it's looking good. All right, so I now know that my audio has been dropping out every time I use the timer on my watch. So I've got the watch on airplane mode, and we're going to do this again. All right, so let's pull these out. Oh, that's a nice flow. All right, and go. 1.4 liters. So that's 1.4 liters per minute. I've doubled the original flow of my NFT channels. Now, just because I'm interested to see how this affects the NFT system, I'm going to leave it at this and see what happens. Because, the best way to answer questions is to just do it yourself. And now, just to confirm that I needed that larger pump for use with this 19mm piping, I've attached the old pump, the smaller pump, to the system, and we'll do a test of the flow per minute with the old pump and the 19mm piping. So it's not as strong a flow. So with my old pump, even with the 19mm tubing, I'm still only getting about 700 mils per minute, which means that the new pump is actually doubling the flow rate of each of my NFT channels. And I'll quickly show you how the adjustment on the 6-port manifolds work. That's at full, and as we turn the adjuster, you can adjust the rate of the flow. So I hope you enjoyed this episode of Hoochos. It was really interesting to find out how all of the different diameters of the pipes interrelated and how they affect the flow leading up to the entry to the channels. Anyway, and I hope to help you move through some of the problems that I had setting this up uh, without having to do it yourself. If you like the video, give us a thumbs up. If you haven't already, subscribe for more. Happy hydroponicking. I'll see you next time.